This is it. I'm done. At least I will be in about an hour and a half. I am finished. This is the last review that you're going to find at www.nkinfinity.com. This is my last ditch effort to try to show you all the different kinds of problems and all the different ways they can ask the same silly questions over and over again. Whew. And I am tired. Man, I can't even, you don't even have any idea maybe how long these things take to make. I think I spent another 4 hours on today's. I don't even know if this one's the right one. I think the problem, yes, good, I've already, I got the accurate one up top. I don't know what I was doing. All right, so anyway, enough of me complaining. Because you know, nobody wants to hear that. My name is Mr. Krause. You can call me Mr. Key for the next little while. You got to study, kids. I've tried to come up with all the different kinds of questions I've had, and if I didn't think I covered it in any of the others, I tried to make a couple of them. Like, here's 3 probable kinds of questions. All 3 of these questions are a little bit different from each other. So, I think we got 25 questions. And a couple of new ones, and a couple of old ones. Like, this one's going to be new here. And a couple of really cool ones. I have to tell you, this is probably the best one I've written so far. So, I'm glad you're here, and I hope you're ready to study. So here's how it goes. First things first, we need a common denominator. So in this case, it should be obvious that the common denominator is 2x. By the way, if you haven't gotten it, get over here to NK Infinity, print the document, download it, whatever you need to do, and watch it. You know, that's on you. So negative 2x. I hate having those negatives there. I'm going to move that in a minute. 2x equals 2x. So this first one's like maybe a simple 2-point question. Not much going on here. The only hard part, maybe this minus right here. Oops. And if you write a 3 instead of a 5, or 5 instead of a 3. Oh, that's better. Now I'll stop complaining. All right, so don't forget this minus really goes here. Now, once I have all the common denominators, I don't need the denominators anymore. All I can do is set the numerators equal to x minus 6 minus 3 is equal to negative 5. So this is x minus 9 equals negative 5, or x equals 4. Now you should check your answers, but I'm pretty sure that's right, and I'm way too tired to check. You see this minus here? This minus really is a problem. I hate these minuses, so I'm going to put it right here. It's the same thing. It means the same thing. So this is x plus 2. I hope you recognize this as x plus 2, x minus 2. And this one's x minus 2. So this one's missing an x plus 2. And so is this one. That's weird. So that's our common denominator. This one's not missing anything, so we're just going to leave that. So the common denominator is x plus 2, x minus 2. X plus 2, x minus 2. X plus 2, x minus 2. And then we got to change the numerators. Now, we got to be a little bit careful here. This is x plus 3 times x plus 2. It's a binomial times a binomial. So you have to FOIL that, or you have to double distribute that. And then this one has nothing to do. And this one is negative 3 times x plus 2. Now, once you have a common denominator, you don't need the denominators anymore. And we'll set the numerators equal to each other. So I'm going to double distribute this. So that's x squared plus 5x plus 6 minus 5 equals negative 3x minus 6. Now everything's going to come to this side. So I'm going to add 3x. And this is minus 6, so I'm going to add 6 here. So this gives me x squared plus 8x plus 7 equals 0. I'm going to factor this thing. X plus 1, x plus 7. So my two answers are x equals negative 1 and x equals negative 7. And I can't stress enough, please, on the day of your test, take the time to check your answers. Make sure they both work. I'm pretty sure both these work. I'm going through this quickly because, quite frankly, I'm tired, and I don't need to get 100 on this. You just need to understand how to do the problems. Now, this next problem, albeit looking rather simple, is a little bit problematic. And there should be one thing that's standing out at you right now. I'm going to drink some coffee while you think about it. Well, let me just go through and put these things in parentheses. And I hate this minus here, so I'm going to get rid of it. Put it right there. Okay, so did you see it? Did you see what's going on? This thing is backwards. That should be x minus 5. So I'm going to turn it around, but in order to do so, I have to introduce a new negative. I like to call it the -1 rule. It's in quotes. Don't somebody look up the -1 rule. You know what it's going to say? Mr. Krause told you it wasn't a real rule. That's why you're not finding it on the internet. That's what it says on the internet. Look it up. Go ahead. It'll say it. All right, so our common denominator, let's check this out. We got -3 over x minus 5. I don't know why I had to make such a long line. Somebody left me a voicemail. Why would anybody leave me a voicemail? Plus -2x over x plus 5, x minus 5, equals 5 over x minus 5. All right, so my common denominator should be pretty obvious. My common denominator is going to be, and I'm going to put them right here, x plus 5. So I'm going to add an x plus 5 here. But if I do that, I got to add an x plus 5 here. I'm actually not adding it. I'm multiplying it. This one's fine. This one's needing an x. Oh, this one needs an x plus 5 as well. That's weird. Again, once I have all the numerators or the denominators the same, I don't need them anymore. All I got to do is make sure the numerators add up to there. So I get -3x minus 15 minus 2x equals 5x plus 25. This gives me -5x minus 15 equals 5x plus 25. I'm going to bring these 5x over. So I get 10x, and then I'm going to subtract this 25. That's a 25. And that equals -40. So x is equal to -4. Bracket in, make yourself look all professional-like. So this is a 2-point question. I'm going to come right back to it. I'll be right back. All right, I'm going to show you 2 ways to do this problem that are both acceptable ways to do it. I'm going to show you the easy way and the hard way. But I want you to notice something. And when you start a problem, I want you to read it thoroughly, and I want you to highlight words like explain, justify. The word explain, if you look it up in the Krause-Webster dictionary, means use words to explain your answer. So it is not acceptable to do some math and say no. You have to write a few sentences. That's what the word explain means. Got it? All right, don't forget that tomorrow, Friday, or whenever you take the test. So we're going to divide 3x minus 2. This is the hard way. We're going to do the hard way first. We're going to divide it into this thing, 6x cubed. And I want to do this just to practice long division. This is not the way I necessarily would do this question, but it's certainly doable. And I didn't leave you a lot of room, so write small. So we're going to put 2x squared here. This gives me 6x cubed. 2x times -2 is -4x squared. Subtract, add. I get -21x squared minus 31x. Subtract 21. I guarantee I'm going to need a calculator soon because my brain is not functioning. -21 times 3. Not -21. I got to multiply something by 3 to get to 21. 7. 7 times 3 is 21. It's actually -7. -7 times -2 is positive 14x. Subtract, add, subtract. Wow, that's really bad. This doesn't look like it's going to work out. What's going on? Whatever. So this is -45x. Oh, it's going to work out perfectly. Plus 30. And then I'm going to do what? Minus 15. So 15 times 3 is -45. X. 15 times -2 is positive 30. If I subtract, I add, I subtract, I get 0. So since I was able to divide 6x cubed minus 25x squared minus 31x plus 30. By the way, you would spread this out over this whole problem. Since I'm going to do it two ways, I need some room. Since I was able to divide by and get a remainder, keyword, of 0, I know that 3x minus 2 is a factor of the polynomial. Something to that effect. All right, so the easier way is to do the remainder theorem. Now, the way the remainder theorem states is if this is a factor, let's say the 3 wasn't there. If x minus 2 is a factor, positive 2 would be the root. So this is how you got to explain it. If 3x minus 2 is a factor, then x equals positive 2/3. Remember, you're going to solve it. You might have to do that work off to the side. Man, it's got another tweet. Metallica pops on every time, man. It drives me crazy. I love it. Move that 2 over, divide by 3. Then x equals 2/3 must be a root, which means when I evaluate the function at x equals 2/3, I will get 0. Something to that effect. And then you got to show it. F of, well, you shouldn't call it f of 2/3, but you need to go through that. 6 2/3 cubed minus 25 times 2/3 squared plus minus 31 times 2/3 plus 30 equals 0. So since this math, whatever, equals 0 by the remainder theorem, we know 3x minus 2 is a factor. Okay, this is the same kind of a problem. I'm gonna do the. I would, if I was you, practice the long division just to make sure it works. So I'm gonna do it. 3x minus 1. 9x cubed minus 27x squared plus 20x plus 4. Let's try to make that look like a 4. So this is going to be 3x squared, so that's 9x cubed. 3x times 1 is minus 3x squared, minus plus. That's the hard part. Don't forget that. That's weird, right? So this is negative 24x squared plus 20x. Multiply by what? Negative 8x. And you get negative 24x squared plus 8x. Subtract, it means we're going to add, we're going to subtract. I get 12x plus 4. This does not look good. Oh no, it's looking pretty good. Multiply by 4. 4 times 3 is 12x. 4 times negative 1 is, oh man, this wasn't supposed to work out. Oh, yeah, 4 times negative 1 is negative 4. Right, so I subtract, I add, and I get a remainder of 8. So one of two things happen. One, you done messed up. Or two, it just doesn't work. So the easiest thing to do is we're going to store in, if 3x minus 1 is a factor, then set that equal to 0, and x equals 1/3 must be a root. So that's what I'm going to come over to my calculator and check. So I'm going to come over to my calculator. I'm going to go 1 divided by 3, control var x. Try to use x. And 9x cubed. You got to go back to the original. 9x cubed. Minus 27x squared minus 27x squared plus 20x plus 4. 8. Do you see how that matched? Do you see how that matched? That means you did the math right. 8 matches this 8 over here. Therefore, you did the math right. So, since 3x minus 1 does not divide into the polynomial evenly, we know that 3x minus 1 is not a factor of the polynomial. Can I stress something enough? Do you see how messy I'm being? That's because I've crammed it in because this document is 8 pages long. If they give you an entire page to do your work, do it neatly, do it again neatly if you do. If you didn't get the right answer, do it again neatly. Neat, neat, neat. As neat as you can be makes your grader a lot happier. And a happy grader is a more friendly grader. And a more friendly grader is well, it's just a teacher sitting in a room really bored, but whatever. Okay, kids, let's get ready to rock and roll. Now, verify the identity is another fancy way to say prove. And if you see the word prove, you are only allowed to mess with one side. Not two sides, only allowed to mess with one side. There's a problem. 20. Put it right here. Just saw it. So we're only allowed to mess with one side. You mess with the more complicated side. Now, I guess you could try to make one look like that, but it would never happen. So what we're going to do is going to rewrite this stuff the way we know how to do it. Yes, I know you probably haven't seen one of these in a while. Cotangent is cosine x over sine x times sine x over 1 times cosine x over 1. And we want to make sure that's equal to 1. So I think I can get rid of the sines. And I'm left with cosine squared. So what I end up with here is sine squared x plus cosine squared x equals 1. Well, doesn't cosine squared plus sine squared equal 1? You're damn right it does, but you can't stop here. See, I would have a bunch of kids on my test dates stop right there. I know you know that's true, but the last step is to write 1 equals 1, and this shows the proof. Well, don't write that. There it is. Shows the proof. Boom, done. Ooh, my phone is updating its operating system. All right, I'm having a heck of a time getting these to pop up right. Sine theta minus 1. Is it squared? I thought it was squared. No. So in this case, I know you all hate fractions, and the left side kind of looks, well, either way, I'm going to do this either way. I'm going to do it two different ways. So the first way, I'm going to take this one. It looks a little more complicated. Now, if I asked you what 3/8 plus 2/8 were, wouldn't you say that's 5/8? Well, can't I go backwards? Or if I told you x plus 3, x over 8 plus 3 over 8 is equal to x plus 3 over 8. I can take something from this side and rewrite it as two fractions. And that's why doing this way is a little bit trickier. So this becomes sine theta over cosine minus 1 over cosine. Now, if I combine those, they already have a common denominator. If I combine them, it would just be sine theta minus 1 over cosine theta equals, keep this coming along for the ride, tangent theta minus secant theta. Well, what is sine over cosine? Isn't that tangent theta? What is 1 over cosine? That's secant theta. Okay, I'm done. Tangent theta minus secant theta. Another way I could have done this is not to mess with the left side. In this case, either side would have been okay to start with. I could have said, okay, I know that tangent is sine theta over cosine theta minus secant is 1 over cosine theta. Then I could say, oh, we have a common denominator. The common denominator is cosine theta, and my numerator is sine theta minus 1, and that equals here. So either way would have been acceptable. This one's a little funky. Algebraically proved. Now, what we had a problem where the kids were doing this. By the way, the state would say something like, oh, this should say 27, by the way. Gosh, that problem did not come out right. The state would come out, and x cannot equal 3. So we had kids just plugging 3 in or doing some weird stuff. This is just domain. It's useless. It's like noise for you. For a mathematician later on, that's very important. For most math kids, you should probably understand what that means. So the right side's more complicated, so I'm going to adjust that. Now I know in order to add fractions, I need a common denominator. So it looks like my common denominator is going to be x cubed minus 27. Well, isn't x cubed minus 27 over x cubed minus 27 really just 1? Minus x cubed minus x squared plus 3x minus 20. Well, here's the tricky part about this problem. A little bit tricky. You have to actually distribute that minus. The minus goes here, that minus goes here, that minus goes here, and that minus goes here. So what I end up with is x cubed minus 27. These x cubes cancel. That's the highest degree term, x squared minus 3x. And what is negative 27 plus 20? Minus 7. Does that equal x squared minus 3x minus 7 over x cubed minus 27? You doggone straight it does, Skippy. All right, so pay attention, especially if you're one of my students. I might have messed you up on this. I want to make sure you understand something. So the June 2016 test had a problem similar to this, where because of where they asked you to round, you could do the problem either way. But I want to make sure I stress on this question. Stress it. That if it doesn't say compounding continuously, don't use PERT. Don't use P equals e to the RT. Let's just do simple growth on this question. So we're going to do 330,500 is equal to, the start value was 250,000. 1 plus, now what rate are we getting? It doesn't say. That's what we're looking for. So we'll call that rate to the 7 years. So just like anything, we're going to get the weird thing alone. We're going to divide by 250,500 or 250,000. By the way, just leave it like that. I mean, if you want to get rid of these zeros, that's fine. But other than that, just leave it. So I get 3305 over 2500 equals 1 plus r to the 7. Now, I'm not looking for an exponent. My exponent is not a variable. Since my exponent is not a variable, I'm going to raise this thing to the reciprocal to get rid of that exponent. So this becomes to the 1. So if I raise this side to the 1/7, I got to raise this side to the 1/7. And that I do need my calculator for, because nobody knows that. So control division. There we go. 3305. I don't even like that. 330,500 all over 250. All right. And we're going to take that sucker. Forgot to put my parentheses on it. And we're going to raise it to the reciprocal. Raise it to the 1/7. Raise it to the reciprocal. Oh, what? What is that? You piece of crap. Oh, I guess that's the exact answer. There we go. 1.04 blah, blah, blah. So we get 1.04. Don't round yet. 0.6837. I can't recommend you never round until you're ready to turn in your answer. Well, I still got to get r by itself, so I got to subtract 1. Subtract 1, so I come over here, I subtract 1. And I get 0.04, don't round yet, so r equals 0.0406837. But I want it to the nearest 100%. So I got to take this thing, move the decimal twice, and I get r equals 4.07%. That's my answer, kids. So I want to show you the 3 or 4 different ways you can be asked basically the same question. But I'm going to do that next. So Miss Lamparella won the Powerball lottery last week. Well, not really. She wouldn't need to invest her money if she won the Powerball lottery. She's got to figure out how to spend it and give it away. So what she did was she won 4 out of the 5 plus the Powerball. And if you look that up, that's a $50,000 winnings. She found a bank that promised 3.505% interest compounding yearly. Well, compounding yearly is just interest. Simple interest. So the value is equal to 50,000. Oh, I didn't add a problem. How much will she have in 10 years? I'm going to have to fix that. Hope I fixed it for you before you got to it. Sorry if I didn't. So 50,000, 1 plus, I always do 1 plus 0.0305. I know that can be written as 1.0305. I just don't to the 10. So I can put that in my calculator. I'm going to compare all these. Now this is semi-annually. That's twice a year. So this is going to look a little bit different. It's going to be value equals 50,000. 1 plus 0.0305. But now since I'm semi-annually, I'm going to divide by 2 to the 2 times 10. Quarterly, that's 4 times a year. There's 4 quarters in a game, 4 quarters in a dollar, 4 quarters in a, I don't know, something. Value is equal to 50,000 basketball game. 1 plus 0.0305 divided by 4 to the 4 times 10. Now finally we've got compounding continuously. So these are the ones, if I'm just basic straight up interest, I'm going to use one of those 3. If it says compounding I feel like I'm going comatose. Compounding continuously, you got to use value is equal to whatever you want to call this. A equals P equals whatever you want to call it. P e to the RT. This is for compounding continuously only. So in this case, we're going to kind of do it the same way. 50,000 times E to the 0.0305 times 10. And I'm just curious what the different values is. Values are, so I'm going to use my calculator. And clear this up. So 50,000 parenthesis 1 plus 0.0305, right? Raised to the 10. 67,000. What you're going to find, I think, is this one probably gives you the most. $67,522. $22.73. It's not going to be much different. So now we're going to do that same thing, but now we're going to take this and divide it by 2 and take this and do 2 times. Enter. 67,675. 67,675. Now when you take a class in finance, 27 cents, you'll find out why you make more on compounding than you do on just straight interest. So that's just if you take a class in financing, you'll figure it out. So we're going to do the same thing now. This one should be a little bit more than that. We're going to multiply by 4, and we're going to divide by 4. It should just be a little bit more. $67,752.82. So they're all slightly, notice how it's getting up. If I did monthly, it would be even a little bit higher. Monthly, by the way, we would do what? Divide by 12 and then multiply by 12. And 67,805. Now I got to do it the other way. 50,000 times E. Now this can be a little bit different. Of 0.0305 times 10. Now this should be just a little bit more than all of those at all. $67,837. $67,831.25. So that was just a little lesson on all those interest rate formulas, and that's going to be a great one that we do overnight. But if you're watching this on videos, you're okay. Oh my God, I love these questions. I'm going to show you how to do these graphically at the end, not at the beginning, because I don't want you to be like, oh my God, it's so easy to do graphically. I'm going to show you. If you have the TI Inspire. If you don't, you're sort of sunk a little bit. But it doesn't matter anyway. You still got to be able to do it algebraically. So on the mock final, this drove my kids cray. So here's how it works. It's very, very complicated. What we're going to do is going to get y by itself on this second equation. So I'm going to do 3x minus 20 equals positive 2y. All I did was move that over there and that over there and divide by 2. Now that alone is already causing somebody to have a convulsion because the F word is in there. And you're like, F that effing F thing there with the F fractions. We don't like those things. Don't worry about it. It'll be okay. This is y. Y is equal to this. So everywhere I see a y, I can replace it with that. And there's my y. So we're going to take it and we're going to store it in there. So 2 times, now y, 3 over 2x minus 10 plus 5 minus x plus 3 squared equals negative 59. All right. This is really just minus 5 here, right? So we're going to distribute. 2 times 3 halves is 3x. See how nice that was? 2 times negative 5 is negative 10. Minus. Now that minus, holy crap, is that a tough minus to deal with. You've got to double distribute this, but you're going to have to leave it in parentheses. So x squared, this should be a 3, by the way, plus 6x plus 9 equals negative 59. Now that negative has to be distributed. It is a badass negative. I can't say it any other way. Negatives are going to crush you if you don't pay attention to them. Pay attention to negatives. Like that negative person. You got to pay attention to them so they feel better about themselves. Help them out. Help out the little negative. Pay attention to it, please. All right? Otherwise, it's going to bite you. All right. We don't like that. So 3x minus 10 minus x squared minus 6x minus 9 equals negative 59. Oh my gosh, all these doggone negatives. We're going to move over here. Now, because my x squared is negative, I have to move everything over to the right side. So we're going to have nothing left on this side. And we're only going to have this one lone x squared over there. So I'm going, this is minus 3x is what I have here. So when I bring it over, it's going to be plus 3x. And this is minus 10 and minus 9. That's 19. So we're really going to add 19. So that gives me negative 40. So I get 0 equals, now I got a factor. Factoring's not too bad here. X plus 8, x minus 5. So my two answers are x equals negative 8 and x equals 5. Now, could you please do me a huge favor? Don't get so excited that it worked out that you forget to do the y values. You still have to get the y values, kids. So we're going to plug that sucker right into this equation right here. So y equals 3 over 2 times negative 8 minus 10. Y equals, this is negative 12. Let's see, that's negative 4, negative 4, negative 12. That's negative 22. Wow, that's ugly. And then I'm going to plug the 5 in. This is going to be even uglier. 3 over 2 times 5 minus 10. Well, 3 over 2 times 5, that's 2.5, 7.5, 7.5 minus, that's 2.5, the negative 2.5. So y equals, I'm guessing, negative 2.5. So my final answer is, and I'm going to erase this, you would have plenty of room on the day of the test, but my final answer is negative 8, negative 22, comma, 5, comma, negative 2.5. Now, we're going to check it later. You could just stow them in and check, and we're going to do that. You could do that as well. You know, let me do that real quick. So we've got negative 8, control var x, negative 22, control var y, shut up, y, and then I'll type the equation in. It's 2 parentheses, y plus 5 minus parentheses x plus 3 parentheses squared. And if it's right, it should be equal to negative 59. Yes. Now let's check the other one. 5 stow x, 5 control var x, and negative 2.5 control var y. Type this in again. It should be negative 59. Yes, it is. All right, so that's how you check that. I'm going to show you graphically in just a minute, but we're going to do both these. So again, we're going to solve for y. So we get 2y equals x plus 4. Divide by 2. Divide by 2. So I get y equals 1/2 x plus 2. I know. Another fraction, Mr. Krause. We hate fractions. This is y. It's going to go in for y. So 3 times 2, 1/2 x plus 2. This time I have to multiply by 2, so I got to be careful here. Minus 1, parentheses squared, minus, oh my gosh, another one. There it is. I purposely put those in, kids, just because I want to drive home a point. You must pay attention to them. This is x plus 1 squared equals 92. So we're going to distribute here. So I get 2 times 1/2 is just 1. So this is x plus 4 minus 1. So this becomes 3 times, that's x plus 3 squared, x plus 3 times x plus 3, minus x plus 1 times x plus 1 equals 92. Double distribute. Don't distribute at 3 yet. Let's double distribute all this. I get x squared minus 3, excuse me, plus 3 is plus 6x, plus 9. Don't worry about that minus for now, but you're going to have to take care of it. Ooh, I almost forgot the 3. It's like that 3 out there. You got to take care of that as well. This is x squared plus 2x plus 1. Now we're going to distribute not only are we going to distribute this 3 over here, we're going to distribute this x too. And it should equal 92. So I'm going to do it up here. So I get 3x squared plus 18x plus 27 minus x squared minus 2x minus 1 equals 92. Since my x squareds are positive and they're on the right, or they'll end up being positive, I'm just going to leave them there. So 2x squared, 18 minus 2 is plus 16x. 27 minus 1. 27 minus, I don't know why I just did that. Minus 92 is what, minus 92 equals negative 66. So minus 66, because I brought the 92 over. So I can take out a 2. I'm left with x squared plus 8x minus 33 equals 0. X plus 11, x minus 3. And my two x answers are x equals negative 11 and x equals 3. Now I want the y value. So I'm going to go plug this into this equation right here. So, oh man, that's going to be ugly. Y equals 1/2 times negative 11 plus 2. So that's negative 5.5 plus 2 is negative 3.5. So I think that's the right answer. And let's plug in 3. Okay, another ugly answer. Y equals 1/2 times 3 plus 2. So that's 1.5 plus 2, that's 3.5. Y equals positive 3.5. So it looks like my answers are negative 11, negative 3.5, comma, 3, comma, positive 3.5. That's really weird. I should check them. I would definitely stow them, type in the two equations, and make sure they work. But I also want to show you how to check these things algebraically. Or using your graphing calculators. If you have a TI Inspire. If you don't, I don't know if this, I don't think you can do this on the other calculators. That 5 shouldn't be there. I don't know why it is there. So anyway, let's get going. We're going to take out the calculator. Hold on, I'll be right back. I don't know why I say I'm going to be right back. I just have to save the last 15 minutes of video, so if something happened to my computer, I don't have to do that over again. It's always good to save. So we're going to go in, we're going to graph. Now, you can't graph a function because, quite honestly, if you know anything about math, neither of these are functions, I don't think. Actually, this one's a parabola. So that one is. This is a strange-looking parabola. So here's how it's going to work. We're going to go Menu, Graph, and we're going to graph a relation. We're going to graph a relation. I know this is going to freak a bunch of you out. This is cool stuff. We're going to graph a relation. So all you got to do is type it exactly as it appears. 2, parenthesis, y plus 5, parenthesis, minus, parenthesis, x plus 3, parentheses, squared, equals negative 59. There it is. Now, I'm going to go into Menu, Windows Zoom, and Zoom Fit, just so I can see it. See, okay, there it is. It's a parabola. And maybe I need to grab this and just maybe see a little bit more of the parabola. There's our parabola. I told you it's going to be a weird one. Then we're going to press Tab, and we're going to type in the other one. 3x minus 2y equals 20. Now you see where they hit? Those are called the points of intersection. That's all we're going to find. So we're going to go Menu, Analyze Graph, Intersection. Now in this case, oh, does the same thing. Negative 8, negative 22. Menu, Analyze Graph, Intersection, click, click. There it is. Winner, winner, chicken dinner. And we're going to do that. We're going to practice that one more time on the other one. Because I never checked those. I'm going to check them right now. Just to make sure I did get the right answers. So, actually what I should do is just move that over. I can't do it. So, let's go back into my calculator. Get rid of that crap. Go back into calculator mode. And I'm going to go into Menu, Graph and Edit, Relation. 3, parenthesis, 2y minus 1. This is just a great check. It's an easy check. It's not going to really help you out with the problem so much because, quite frankly, you got to show all that algebra anyway, but at least you know what the right answers are. X plus 1, parentheses, squared, equals 92. Ooh. Oh yeah, it's a hyperbola. Weird one. And then 2y minus x, tab, 2y minus x equals 4. There they are. So I can't see this one, so I'm going to grab here, and I'm going to drag it over a little bit, and I'm going to go Menu, Analyze Graph, Intersection. Ooh, what the heck? Menu, Analyze Graph, Intersection. Oh, it's asking me here. Oh, what the heck? Oh, that's weird. Okay, I didn't know it would do this, so this is going to be a little bit different. I didn't know it could do this, so we're going to go Menu, Analyze Graph, Intersection. Now, see it says first corner? It wants us to draw a box. It wants us to draw a box around it, so I'm just going to click here, And see how I'm drawing a box? And there it is, negative 11, negative 3.5. Got that one. Menu, analyze graph, intersection. Drew a box around that one, and there it is, 3.5. Got them. All right, there's a little trick for you. Oh, this stupid question. This question comes up for some reason all the time. Average rate of change. They ask it all the time. Average rate of change. It's just slope. Now you need to know that slope is y is on top, x is on bottom, and you got to go in some order. So 2 minus 1, you're going to take the second point and subtract the first point. Doesn't matter, as long as you do it in some order. So they want you to go from negative 5 to 3. From that point to that point, I want to find the slope. From negative 5 to 3. That one I got to do some work. So let's do this one first. Slope, or the AROC, the average rate of change, is equal to, what's the y value here? What is this point? 3, 6. So 6 and 3 go here. And this point is negative 5, 0. So in for y goes 0, and in for x goes negative 5. So that's 6 over 8. Notice it's positive. If you put that on your calculator, that's also equal to 0.75. Let's do slope here. We're doing a different color. This one's a little bit easier. I'm going to take negative 8.5, subtract off 7.5, all over slope, equals. Since the 8.5 went first, this is 3 minus negative 5. So this gives me negative 16 over 8. Oh, that's just negative 2. So that's higher than this. Negative 2 is quite a bit higher than that. Now this one, we got a little bit of work to do. We actually have to figure out what is h of negative 5. So negative 2, negative 5 plus 1 squared plus 6. I'm showing you that, but that's not how I'm going to do the problem. I'm going to come over to my calculator and do this sucker. So negative 5, control var x, enter. And then I'm going to type in the left side, negative 2, parentheses, x plus 6, even though I think I wrote plus 1, and that's because negative 5 plus 6 is 1, parentheses, squared, plus 6. So 4. So that's point is negative 5, 4. Now I got to do the other one, h of 3. Showing my work. Now I'm just going to do 3, control var x, enter, and negative, ooh. So that point is, what is that, negative 156? So that point is 3, negative 156. All right, so now I got to do slope for this one. Let me do it in a different color, purple. So slope, or AROC, is equal to negative 156 minus 4 over 3 minus negative 5. Notice the denominator is the same every time. This is 8. And then that's negative 160. So that's equal to negative 20. And there's your biggest average rate of change. It doesn't matter about whether or not it's negative or positive. It matters the magnitude of it. And the magnitude of that's 20. The magnitude of this one is 2. And the magnitude of this one is 0.75. So that's the winner. All right, a couple of these ones again, but I'm going to save and I'll be right back. All right, I said a couple, but I only have one. But these are on every day. I think I put one of these on every day. So check these ones out. They're just a different way to do a problem. You need to know that when you have something written like this can be written as a rational exponent, kind of like this, where this number is the denominator and this number is the numerator. So that's b to the 5 over 3 is equal to a to the 5 over 9. Now it says solve the following for A. That means you got to get A all by itself, which means I need to get rid of that 5/9. The easiest way to get rid of that 5/9 is to raise it to the reciprocal. Now when you raise an exponent to another exponent, you're really multiplying. All right, so when I multiply, these 9's cancel, these 5's cancel, that leaves me A equals, now these 5's cancel, and how many times does B go into 9? 3 times. So B cubed. There it is. Simplify the following expression. Now when you're done with this, you should check it, and I'll show you a real quick way to check it. It's not that quick, but it's kind of quick. We're going to just do it 2xi, 3x minus I, 3x minus I. I think what I would do here is double distribute first. So 3x times 3x, we're not going to worry about this right now, is 9x squared. 3x times negative I, and 3x times negative I is negative 6xi. And here comes the tricky part. Be careful. That's negative times negative, which is positive I squared. Well, okay, alert should be going off in your head. This is really just negative 1. So now we're going to distribute. And what we get is 18x 18x cubed I plus minus 12x squared I squared minus 2xi. We're not quite done yet because of this thing right here. So I get 18x cubed I minus 12x squared. Now this really makes negative 1, so we're going to turn this into a positive, correct? Minus 2xi. Now this is one of those ones that you absolutely must check. Must check. So you come over to your calculator, you're going to store any number you want in for x. I'm going to store that number into x. It doesn't matter what you store in for x. It makes no difference. Don't pick an average number. Don't pick a normal number unless you're testing the answers. If you're testing the answers, you have to use whatever those are. But if you're not, make up a number. I'm going to show you can make up one as dumb as that, and you can still get it right. So we're going to type in the original, 2xi, 2x times I. It's not going to let you get away with just writing xi normally. Parenthesis. 3x minus I, 3x minus... And don't type the I button. And you got to use this imaginary number I, and then squared. And it's going to be an obnoxious number, really obnoxious number. Like crazy obnoxious. Now we got to type in our answer. 18x cubed. 18x cubed. I think it's I, right? I. Plus 12x squared. Plus 12x squared. Minus 2xi. Now, if we did this correctly, we're going to get that same obnoxious answer. This is where you cross your fingers. You're like, please, 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 please. Yeah. Yes. Look how obnoxious it is, but they match exactly. You know you're right. When you know you're right, you star that sucker and never look at it again. It's perfect. All right. Yes. So I modeled this one after one of the equations or off one of the old tests. It's actually a really good question I just wrote. I love this question. So using the identity, find the value of sine theta. You'll notice sine theta is not even in the problem anywhere. If cosine theta equals negative 0.3. So we're going to use this identity. This is one of those identities you got to know. Tangent squared plus 1 is equal to secant squared. The other one is cotangent squared. Theta plus 1 is equal to cosecant squared theta. All right, so how are we going to do this? How am I going to even plug this in? You got to remember a few things. Tangent is really sine theta, so sine squared theta over cosine squared theta, plus 1 equals, and secant is really 1 over cosine squared theta. So I can plug in negative 0.3 in for cosine. Okay, that's not a problem. We'll do that. So it's sine squared theta over negative 0.3 squared, because it's just cosine we're plugging in, not for cosine squared, plus 1 equals 1 over negative 0.3 squared. Well, this is just a number, and I'm going to subtract this 1 over. So I'm going to put that in my calculator. 1 divided by parenthesis. I don't really need the negative, but you might as well put it in. Negative 3 squared. Enter. Minus 1 equals 10.1 repeating. So sine squared theta over, well, I don't know what that is, negative, oops, don't do that, parentheses, negative 0.3 parentheses squared. So over 0.09 is equal to 10.1 repeating. Well, how do I find sine squared? I just cross multiply. Oh, put this over 1. I get sine squared theta is equal to 0.91. Okay, how do I get sine theta? You take the square root. And when you take the square root, you put a plus or minus. So sine of theta is equal to plus or minus. So we're going to take the square root of our answer. 0.9539. 0.953939. Now it said rounded to the nearest thousands place. That's this decimal. So this is plus or minus 0.954. Now if you leave it like that, this might be a 4-point question. You only get 1 point. And that's because there was one additional piece in this problem, and that was you were in quadrant 2. And you need to remember that all students should take calculus. And sine is positive in the second quadrant. So the answer to the question is 0.954. Badass question. Love that question. Can't wait to go over it in review. I know, y'all think I'm freaking crazy. It's true. It's true. That's why I told you I'm done, man. After this, I'm crazy done with these. All right, I'll be back. So all of you iPhone lovers, I got a Galaxy. Don't like iPhones. Just bought the S8. Now I'm broke. Whatever. The new Apple iPhone 10 is supposed to come out this fall. It's supposed to be amazing and stuff, and like it's going to be awesome. Whatever. The 10th anniversary of the first iPhone. Let me just tell you a quick story. When the first iPhone came out, I was in Disney. It was 2007, and I was in Disney. And these two rich, snobby people were on the tram with us, and they're both got their iPhones out. And they're like, oh my God, they're like pinches and zins. Look at it, it's so cool. And they just kept showing it to each other. Yeah, they were really annoying. I'm not going to lie and stuff. Who needs a vacation? This guy. I'm teaching summer school this year. Please don't fail if you live anywhere near Hilton, Greece, Athena, Greece, Arcadia, or something like that. You're probably going to be in my class, and I don't want you to have failed. Don't fail. Work. So, about 1 month after the last iPhone went out, Kayla and Jordan were, I don't think I spelled that right. Maybe I did. Were at the store and were mad as hell. They had to wait 33 minutes. When Kayla complained to the manager, they told them, this is why I teach math, kids, and I have to write a speech for graduation, it's going to get rough, that this was not normal, and it was only due to the new iPhone having just come out, whatever. The manager, having just gone through some training, cited a nationwide survey done on all Apple stores that determined that, oh my God, I wrote this afternoon, kids. I was so tired. Man, it looks like a fourth grader threw up on a piece of paper. But the problem's cool. That the average wait time was 25.6 minutes with a standard deviation of 4.2 minutes. Given these these data and a 95% level of confidence. Was their wait time unusual? Justify, kids. Justify means math and words. If you just give math, you only get partial credit. If you just give words, you're not going to get it right. So you need both. So what we're going to do, 95% is 2 standard deviations. So what we're going to do is we're going to take the average wait time, which is 25.6, and we're going to add and subtract 2 standard deviations, which is 2 of these 4.2s. So we're going to come over here. I didn't know where I was going. 25.6 plus 2 times 4.2. 34. So 34 is the high end. And the low end, I don't think we actually need the low end, but we might as well get it. 17.2. So, the Apple stores are confident, are 95% confident that the wait time for their customers should be between 17.2 and 34 minutes. Since 33 minutes lies in this range, we know that 33 minutes is not an unusual wait time. Therefore, the manager is a liar. And I just spelled liar wrong. Liar. I don't think that's liar. Liar. Or he didn't tell the truth. Good. We're done. On the same axis below, graph the 2 cycles of the cosine curve with an amplitude of 3, a period of 4 pi over 3, a midline of y equals 5, passing through this point. I hope by now, because this is like the 4th time I've put these on here, there's going to be one more that you guys are getting good at these. Amplitude is equal to 3. Period is equal to 2 pi over, squeeze me, 4 pi over 3. As soon as I get that, I'm going to go to scale, x scale. My x scale is going to be 4 pi over 3 divided by 4. Well, dividing by 4 is the same as multiplying by the reciprocal. So that's multiplying by 1/4. Go. So this is pi over 3. That's my x scale. And then what else do I need? My midline, y equals 5. And we're going to have to go through this point, 2 pi over 3, comma 2. I hope I gave you the right point. All right, so midline is positive 5. And because it's positive, that means the whole graph got shifted up, right? Since the midline got shifted up. So because of that, wait, did it just tell us to graph 2 cycles, I hope? Graph 2 cycles. Okay, good. So it doesn't matter where we put things. So I'm going to put the y-axis over here. And since it's shifting up, I'm going to put the x-axis down at the near the bottom end of this thing. Not all the way on the bottom, just near the bottom. Now I got to do my scale, so I'll just say every tick mark is 2 or negative 2. And then I got to do my scale for perfect. Then I got to do my scale for the x-axis, and that's what this is all about. So we're going to put those in there. And I do 4 tick marks. 1, 2, 3, 4. You'll see why. Those are for the 4 quadrants. 0, 90, 80, 160, 45, and 33. 90, 180, 270, and 360. So, pi over 3. 2 pi over 3. 3 pi over 3 is pi, and 4 pi over 3. Now, if you do it correctly, this one right here should match your period. One, two, three, four, 5. This is 5. So I'm going to graph this midline. Since it's not part of the graph, it has to be dotted. All right. So what are we graphing, a sine curve or a cosine curve? Cosine curve. Oh, we have one other thing. We got to go through the point 2 pi over 3, comma 2. So we got to find that one. 2 pi over 3, that's right here, 2. That point. It's got to go through that point. Love that. I love that tool. Wouldn't you wish you could just do that with your pencil? That's awesome. All right, so you have to remember that a cosine curve starts at maxes and has a min in the middle, or it starts at mins at the bottom and has a max in the middle. So starts at max, min in the middle, or starts at mins, max in the middle. Well, if you notice, what's right in the middle of this thing? Like if you just looked at this is our thing here. Right in the middle, we're here at the bottom. We got a min. So that means we're going to have a cosine curve that starts at a max, up 3, 1, 2, 3. Ends at a max, 1, 2, 3. And in the middle is a min. Now, in between those are zeros. And they all got to be on these tick marks. You see, we're always on these tick marks right here. Right? So, now I graph my curve. Now I got to do it one more because it said 2 cycles. 1, 2, 3, and 4. So it's going to start at a max. I can't see that pen anymore. Right here. Sorry. Right, that matches with this one. These tick marks aren't very... Start at a max, end at a max. In the middle, which is right here, it's going to be at a min. In between those, you're going to be on the zeros on the midline, and you just keep graphing. Just keep graphing, just keep graphing. By the way, if you had to write the equation of this one, do you think you could pause it and try to write the equation? I'm going to start it. Y equals. All right, pause it. I'm going. All right, because it started at a max, I know it's positive. The amplitude is 3, so that's 3 cosine. The period, that's going to be tricky. What goes here is a little bit tricky. X. And then plus 5. Now, the only thing I don't know is this B. That's a little bit tricky. But remember, period, which is 4 pi over 3. The formula for period is 2 pi over B. Right? Period is 2 pi over B. So if I cross multiply, I get 6 pi is equal to 6 pi is equal to 4 pi B. Divide by 4 pi, divide by 4 pi, pi's cancel, I end up with 6 over 4, which is 3 halves. So what does that mean? We're going to finish 3.5 curves in, no, 1.5 curve in 2 pi. And let's see if that makes even sense. Check this out. Right, so this would be 5 pi over 3, and this would be 6 pi over 3. And now isn't that 2 pi? And didn't I finish 1.5 curve in 2 pi's? Yes, keep it going. All right, this one's a little bit easier, not so much maybe. Let's get going on it. Got to take a break. It's 11. So anytime they give you the equation, you're going to write A equals, this is A, without the negative. The negative just means which direction we're going to go. So A is 1.5. Ooh, that's going to be tricky. B is 1/3 pi. It's whatever's in front of the x. As soon as I get B, I'm going to go right to period. Period is equal to 2 pi over B. So I'm going to finish this. Notice the pi's cancel. So I got 2 divided by 1/3, which is the same as 2 times 3, which is 6. Now that I have that, I'm going to go x scale. X scale is period, which is 6 divided by 4, which is, if you do this, it's 1.5. Now we got some issues. Not really. And my midline is y equals -3. Oh, I didn't tell you. I want you to graph this from... Oh, let's just graph 2 cycles. We're going to go down 3 with our midline, so I'm going to put my x-axis near the top. All right, so let's put our midline in. Oh, we have to put scale. Now, scale's a little tricky on this one. Scale's going to be a little tricky. Do you notice how I have a half here? So here's what I'm going to do. I'm going to make this 1. And then this 2. That means every box represents a half and makes my life a little bit easier. You'll see in a minute. So on and so forth. So there's my midline at -3. And 4 tick marks. 1, nothing's changed. 2, 3, 4. But now I got to count by 1.5s. Oh, that's really hard. 1.5, 3, 4.5, and 6. This should match your period of 6. All right, here we go. A sine curve starts on the midline, ends on the midline, and in the middle is the midline. Cosine starts at maxes, mins in the middle, or starts at mins, max in the middle. Sine starts on the midline, ends on the midline, midline in the middle. On the middle in the midline. Midline in the, I don't know what the hell I'm saying. So, it's going to start at a midline, it's going to end at the midline, and it's going to be a midline in the middle. Now, in between those, it goes max and min. And that's determined by the negative right there. Right? Because that's negative, I know I'm going min first. And I got to go down 1.5. So remember, this is 1, so down 4. That's down 1. And then that would be down 2. So we want to go down 1.5. That's why I made every box a half. And we're going to go up 1.5. So it made that a little bit easier. 4 more tick marks. 1, 2, 3, 4. Begin at a 0. End at a 0. 0 in the middle. And then just keep the pattern going. Down 3 and up 3. Down 1.5 and up 1.5. The data below shows the average growth rate of 20 sunflowers planted in new soil that has been tilled with a growth hormone. All sunflowers were 3 inches tall when they were transplanted into the new soil. I guess that's why week 1 they started at 3. So I'm going to pause this and I'm going to put this data in my calculator, but I'm going to show you what I'm doing. Get off of this, get off of this, get off of this, don't save this. And go in here, go right into a spreadsheet, and I'm going to call this age, and I'm going to call this height. Now, maybe you can fast forward if you don't want to watch me. I'm not going to pause it. I decided I'm not going to. By the way, the single most common mistake made when typing in data is not typing the correct data in. I cannot stress enough with you that you do this work twice. You practice it twice. Make sure they match. If they don't match here, you're going to get something like dimensional error or some weird stuff. Now, I don't know. It didn't tell me what kind of a... Determine a model. Is it going to be linear? Is it going to be quadratic? Is it going to be power? Is it going to be logarithmic? Is it going to be exponential? And is it going to be sinusoidal? Let's go through those again. Let me write those, because it could be any one of these. Is it going to be linear? Looks like a line. Is it going to be power? I think if it was power, they would tell you. If it's going to be quadratic. Because power looks like square root. But it also looks like logarithmic. Is it going to be exponential? Is it going to be sinusoidal? Could be any one of those. There's 6 of them. Could be any one of those. Any one of those. So before I do that, I got to go look and see what does this stuff look like. So I hit doc. I go into insert 4. I go into data and statistics, 7. And I'm going to go down here, and the bottom is my age. Those should be all lined up, and this is my height. And then after I see this, I should be able to see what is the general shape of this thing. Ah, exponential. Now I know that I got to go do exponential regression. Got to go do exponential regression. So I go back to this tab. I click here. I go menu, statistics, stack calculations, and I'm going to do exponential regression. Age is my independent, height is my dependent, and I click OK. So there it is. There's my equation. Remember, if you can't see what's in these boxes, highlight them and then look down here. Okay, it'll tell you what's there. So I'm going to write, so the model is the equation. They don't say like, oh, look, that's the model. No, that's not a model. The model is the equation. So we're going to write it as y equals. I'm going to do h of a. It just looks more professional. Height over age. Height of age is equal to a times b. No, wait, what's a? A is equal to, and I didn't tell you what to round to, so we're going to round to the thousands. We're going to round to the thousands place. So a equals 1.941, 1.941, and b equals 1.271, 1.271. 1.271. So use parentheses. It's usually a lot nicer. 1.271 to the A. You know, you can use Y, you can use X. It doesn't matter. What is the average height of a sunflower, midway week 5? So I guess they want us to check 5.5. So H of 5.5 is equal to 1.941, 1.271 to the 5.5. So I need my calculator for that. I can't do that in my head. 1.941, 1.941, parentheses. Whoa. 1.941, 1.271, 1.271, raised to the 5.5. 7.258. I should have told you. Let's round to the tens place on this one. So 7.3. Does that make sense? Well, okay, kind of makes sense. It's right around there. Predict the height after 4 months. Now be careful. This is in weeks. 4 months would be 16 weeks. So I got to put in the 16 now. 90.0. Good enough. Just a quick recursion thing. Starting to get teary, man. We're almost done with all this review. The tears are just because I'm tired. All right, kids, check it out, kids. If you don't know these formulas, start working. You better know these. They're not going to be given to you. Not. You have to know them. Commit them to memory. One of them is probably going to be on the test. So yeah, you got to spend some time memorizing these if you haven't already, because you're going to miss a question. Maybe two. You're going to miss a question. Or you can miss a 4-point question, and 4 points is, that's a ton of percentage. That's like 8 percentage points if you miss 4 points. Boom, you just lost 8 percentage points if you can't do this problem. So make sure you know these. Now, key is, if you see the word or, you're going to write this formula. Probability of A or B, probability of A plus probability of B minus probability of A or B, A and B. Independent. If A and B are independent, this is true. What else is true is the probability of B is equal to the probability of B given A. That's also true. If they're independent, this is true. If they're not independent, then either this is true or this is true. Now, what I want you to notice about these dependent, I like to call these the dependent formula. Take a look at this. Doesn't that look like this? It looks like the independent formula, and then we tag this little piece on in the end. Again, Here's the here's the independent formula. And then we're going to tag this little piece on the end, and that makes it a dependent formula. So if they're telling you they're independent, these are what you know. If you see the word mutually exclusive, or you see the word disjoint, which I don't think I've seen, but mutually exclusive disjoint means that the probability of and is 0. All right, let's get going. I got a couple of problems. Some good ones here too. Given events A and B such that the probability of A is equal to that, probability of B is equal to that, probability of A or B is equal to that. Now, did you see it? I just mentioned an or, and I said a couple of minutes ago, if you see an or, you must write the or formula. Okay? There are other ways around it, but this is the easiest, most productive way around it. So I write the or formula. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, let's see what we got. A is 0.6 plus B is 0.45. And this is 0.75. Okay, so we can find this. It looks like this is what we got to find here. So I'm going to take 0.75 and I'm going to subtract off those two things. So, oops. 0.75 minus 0.6 minus 0.45. So I get negative 0.3 is equal to negative probability of A and B. All right, well, I don't need those negatives, so that's what I got. So, I didn't answer the question. Are they independent or dependent? See, I was able to do the or thing, but see how I'm missing some points here? I don't know. I got 1 point now because I already did half the work, but I got to answer the question. Are they independent or dependent? I guess you could guess, but you got to show some work. If they're independent, then this is true. The probability of A and B is equal to the probability of A times B. Well, I just found the probability of A and B. It's 0.3. So now I got to check, are they independent? Well, if it's true, the probability of A and B is equal to the probability of A times the probability of B. Well, that's 0.6 times 0.45. Does that equal 0.3? 0.6 times 0.45. Oh, I was going to say, I thought I wrote these so they were independent. If you come up with this, they're not independent. Did you guys see where I made my mistake? By the way, there it is right there. Boom. Just got myself a 99. Just failed the test because I made a stupid, careless error. Happens all the time. Did you see it? 0.78, and for some reason I wrote 0.75. That should be 0.78. So if I come back over to my calculator and do this again. Oops. Actually, it's just 0.33, right? So it's, what am I doing? Negative 0.27. Or just 0.27. And what was this again? So you notice they're equal? And since they're equal, 0.27. Sorry about that. Then yes, they're independent. All right, sorry about that. The president of the Hilton Heat Soccer Club had to report out to his board of directors about the athletes in their club. The report indicated that 67% of the girls in the club are scholar athletes. GPA over 90%. Yes. And that 72.5% of the girls also played a second sport. The last statistic the president reported was that 22.2% of the girls played a second sport and are scholar athletes. Find the probability to the nearest hundredths place that a girl in the Hilton Heat Soccer Club is a scholar athlete if you know they also play a second sport. Whoa, 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 whoa. What does that mean? See, I hope you recognize this is just a replacement for the word given. Right? Now, did anywhere in this problem I use the word? Did anywhere in this problem I use the word or? Nope. Didn't use or. Did anywhere in this problem did I use the word independent? Nope. Didn't use the word independent. So in order to do this problem, you have to be very aware of the other formulas that are not independent or. See, here's your independent formulas. Here's your or formula. And here are your dependent formulas right here, right? Not independent. So that formula is, now I'm going to write the information over here. So probability of scholar athlete is equal to, I'm going to write my information because I don't want to use A and B in this case because that would be kind of confusing. 0.674, the probability of two sports, we'll call it two sports, you can call it multiple sports, is equal to 0.725, and the probability of scholar athlete and two sports is equal to 0.222. So the formula for the dependent is the probability of scholar athlete and two sports is equal to the probability of scholar athlete times the probability of two sports given scholar athlete. Remember, this would be, if you stopped here, that would be the independent formula. If you add this little piece at the end, that gives you the dependent formula, okay? But it also could be this. It could be the probability of scholar athlete and two sports is equal to the probability of two sports times the probability of scholar athlete given two sports. I don't know which one they want. We got to figure out which one they want. So they're asking for, let's see what they want. What is the probability a girl is a scholar athlete given they play a second sport? Where's the one given they play a second sport? That would be this equation. So we actually need to use this purple equation. So we're going to put in the pieces that we know. We don't need this. I'm going to get rid of it. And so this is 0.222 equals, the probability of two sports is 0.725 times, I don't know, the thing I'm looking for, the probability of scholar athlete given two sports. I'm just going to divide. Come over to my calculator. 0.222 divided by, 0.725. So 0.3062. So the probability of scholar athlete given two sports is equal to 0.30, don't round, God bless it, 3062 0689. 0689. Now what do we got to round to? Round to the nearest hundreds place. The probability to the nearest hundreds place. So if I had to round this to the nearest hundreds place, I would round this, don't change it, to 0.31. But I really don't like that question, because the next part, I need something more. Well, yeah, about 0.31. So the probability of scholar athlete given two sports is equal to 0.31. All right, that's math. Now you got to pretend like you're talking to your mom and she doesn't know what the hell you're talking about. All right? So you got to explain it to the parents of prospective club members what this means in terms that they can easily understand. What does the probability of scholar athlete given two sports equals 0.31 mean to your mom? So remember, you start with the idea of the given. So you're given, it is a fact that they play two sports. And then we have to talk about scholar athlete. So if you haven't written it, try writing it. So the way it's going to be written is something like this. We know that in our club, the girls that play two, I don't like that. We know that in our club, I'm trying to figure out the best way to write this. I'm trying to write it kind of a nice way. We know that in our club, if we randomly select one of the girls that play two sports, there is a 31% chance they are a scholar athlete. And that's what it means. That's all it means. If I randomly select a girl that is playing two sports, that I know plays two sports, there's a 31% chance they're a scholar athlete. All right, moving on. All right, let me break. And I think I got 3 questions left. So Miss Newman gave me this problem. This is one of hers. I think it was a pretty cool problem. It's actually relatively simple, but there's a lot going on here, and there's a lot of places you can make mistakes. So the state nonprofit organization wanted to encourage its members to consider the state of New York as a vacation destination. Oh yeah, whatever. All those waste of money signs. They are investigating whether their online ad campaign influenced its members to plan a vacation in New York within the next year. The organization surveyed its members and found that 75% of them, 75% have seen online ad. 40% they're planning to vacation. And 15% said they didn't see the ads and do not plan on planning in vacation. All right, so now we got to work through this one. Let's start with 75% of them have seen the ad. Well, where's the seen the ad? That's right here. That's this column right here. 75% have seen the online ad. Okay, 75. Oh, of what? Oh, of 1,000. So 750. Well, if that's 750, isn't that 250? 40% of the members indicated they're planning to vacation in New York. This is planning to vacation in New York. 40% plan on vacationing in New York. 40% of 1,000 is 400. That means 60% are not planning, or 600 of them are not planning on vacationing in New York. And finally, 15% of them did not see the ad. That's this one. And do not plan to vacation in New York. That's this one. That's 15% or 150. And that's all you get, but you can fill out the rest because this would be 450. If that's 750 and that's 450, this has to be 300. And if that's 400, this has to be 100. That's it. Okay, that wasn't too bad. Determine the probability that a member plans to vacation in New York within the next year if they have never been on the internet. So this, if they have never been on, again, that's your given. Given that they haven't been on the internet. Doggone it. So given that they haven't been on the internet, which means the only thing I'm allowed to look at is the people that have not been on the internet. In other words, didn't see an online ad. So we're going to get rid of that. And we're going to get rid of that because the only thing I can look at is did not watch online because they've never been online. So what is the probability that a member plans to vacation in New York given that they've never been on the internet? Well, 250. If they haven't been on the internet, by the way, that means they didn't watch the online commercial. Member plans to vacation in New York within the next year, even though they didn't watch it, 100. So there's the answer, 100 over 250. The volume of space occupied by the latest version of nanobots is growing exponentially. If the scientists and engineers started with 50 cubic centimeters of these amazing bots and they triple in volume every 42 hours, what will the volume of the nanobots be after 3 weeks? All right, so the volume over, well, it's 42 hours. Let's go over hours. The volume over hours is equal to, oh, did you see that? Weeks, hours. Constantly screwing up those units on you. Be careful of them. We're starting with 50. We're tripling. Now, whenever you do a half-life, double life, or triple life, or whatever it is, you have to look for the every word. Here it is, every 42 hours. That goes in the denominator. The everything goes in the denominator. And in 3 weeks, okay, I got to figure out, 3 weeks is 21 days times 24 hours. So 21 times 24 is 504 hours. This, I think I absolutely made this way, way, way too big. I said round to the nearest tenth of a cubic centimeter. Okay, that's just not going to happen. This is going to be a ginormous number. All right, so I accidentally made this too big. So I apologize, because if you come over to your calculator is probably going to break this number so big. So 50 parenthesis 3 parenthesis. So 50 parenthesis 3. Oh yeah, oh man. Raised to the 504 divided by 42. Oh, I thought it was going to be much bigger than that. Okay, that's not too bad. Let's round it to the, I'm going to change this, round it to the nearest 100,000. Round it to the nearest 100,000. These directions were from an old problem. So if I had to round this to the nearest 1,000, that'd be 26,572,000. So that would be 26,600,000. Wherever I ask you to round to, that's no big deal. Finally. Last question. Last review question for the year. And it's Miss Turner's. She just landed a great new job because she kicked butt on the trig test and the Algebra 2 test. Not called trig anymore. The bank locked her in at 3.25% yearly interest rate because she was able to put a down payment of at least 20%. So let's say she's putting down 20%. I should have said putting down a down payment of 20%. So how much does she have to borrow? Well, she put down 20%. So that's the first thing I got to do is figure out how much her down payment is. So 320 times 0.20. You could just multiply by 0.8, by the way, and get to the right answer quicker. Times 0.2, enter. And then I'm going to take I'm going to take the 320,000 and I'm going to subtract off 64,000. Now, that's the hard way to do it. You could have just done this. Times 0.8, because if she loses, those are the same. Oh yeah, those are. If she's losing 0.8, if she's paying off 0.2, that means it leaves 0.8. So whatever, 256,000. So that's the amount she's going to borrow, 256,000. How many pay periods? 30-year mortgage, but this is monthly. We want to know her monthly payment. So that's 30 times 12, or 360. We don't know this. Now, careful, I gave you a yearly interest rate. You got to turn that into a monthly interest rate by putting 0.325 over 12. And now we're ready to rock and roll. She's going to borrow 256,000. We don't know what the payment is. 1 minus 1 plus 0.0325 over 12 raised to the negative 360. Yeah, that's annoying. All over 0.032512. I'm going to just type all this crap in here. See what that is. Now, whatever it is, I'm not going to round it. So control division, 1 minus parenthesis 1 plus control division 0.0325 over 12. Now, did I put the 0 in, by the way? Yeah, I did. Raised to the negative 360 all over control division 0.0325 over 12. 229.776. Don't you dare round. 776,075,431. So now I'm going to divide both sides by that. So I was going to say 256,000 divided by that answer equals that. Now, it didn't say to round, where to round. So if it didn't say to round, you got to round to money. It's money. So her payment is going to be $1,114 and 13 cents. All right, last question for the year for me. Oh my God, this is so exciting. This is it. She can only afford a monthly payment of $1,050. What must her down payment be? Because remember, it said at least 20%. So it looks like she needs to put down more than 20%. So we don't know what she's going to borrow. But we know she can make a $1,050 a month payment. And it's going to be all of this crap again here. Same numbers. Nothing's changing there. You're not changing interest rate. You're not changing time. The only thing we're changing is that PMT can't be 1,000 whatever. So she's got to come up with some more money. We just got to figure out what it is. So 229.776075431. So we put that in our calculator. Times 1,050, we get 241,264. Didn't say, so we got to use money, and 88 cents. Now that's not her down payment. That's what she can afford to take a loan out for. The bank, the house is 320,000, so we got to take 320,000 and subtract off that. And we get 78,700. So her down payment needs to be $78,735.12. For those of you that have spent this year with me and you got to this last question, you must be one hell of a student that wants to do well on the test. I appreciate you guys working so hard. I know you guys appreciate that I've worked really hard. I am so glad this is over. I will not be able to post these videos until June 30th. That is a New York State regulation, and I would like to keep my job so that I can help you out in the future maybe, or help out your younger brothers and sisters. Do me a favor, if you don't mind, please stay subscribed. I might be doing AP Statistics in the future, so if you take that course in the future, it may help you out. Plus, it helps me out. If I helped you out, you can help me out by staying subscribed. And do me a favor, tweet, text, post, tweet, snap, and whatever to your friends, younger friends. Let them know, hey, if you're doing Algebra 2, come, Mr. Kraus can help you out. I appreciate it. Guys, hit that subscribe button, hit the like button, and just keep studying. You only got a little bit more time. All right, guys, I'm out. Bye. It's been one heck of a year, kids. Goodbye.